My name is Praveen and this is my Rube Goldberg machine. Before I start, we have to keep in mind that the law of conservation of energy states that energy is neither created nor destroyed. And at every energy transformation and transfer point, some work is being accomplished. Okay, in this Rube Goldberg machine, I use several simple machines to accomplish this task. I use two simple machines, an inclined plane and a lever. The first inclined plane is here. I use this to start this. And I use another one here so that the train can fall down and hit the ball. My first lever is right over here. This is so that when this bowling pin right here hits this lever, it will cause the other side to move and the dominoes will fall. And the other lever is here. When the domino falls on the popsicle stick lever, it will cause the ball to move up and the ball will go inside the cup. I use various types of energy in this machine. I used gravitational potential energy, electrical potential energy, kinetic energy, heat energy, and magnetic energy. So first, as I release if I were to release this tennis ball on the ramp, gravitational potential energy is being transformed into kinetic energy, rolling down the inclined plane. Next, the ball will bounce on the small stool, converting the kinetic energy back to gravitational potential energy. After that, the ball will fall into this can, which is gravitational potential to kinetic energy. After that, the can will hit this train, and the train will roll on this ramp where kinetic energy gets transferred and triggers the train to move. After that, the train will roll down faster down. This is the cause of gravity pushing down, and it transfers that kinetic energy into this ball. And here also there is an inefficiency because friction on the tracks are causing it to rub, causing heat as a loss of energy. Then when the train hits the ball will move and approach and hit this book. Here there's also the energy transformation is that it's kinetic energy is being applied to the potential energy of the book to fall. And there's also another friction thing happening. As it rolls, the friction of the surface makes the ball to slow down, and as another heat is lost. Then the small book will hit the next book and so on, creating this domino effect. This is potential to kinetic, potential to kinetic, gravitational potential. When the final book here falls down, it will hit that switch and switch of the extension cord that is connected to the power outlet. Here the kinetic force from the book gets transferred onto the switch, where it gets transformed to elastic potential. Then as an outcome, the elastic potential is there's a spring within the switch. Then as an outcome of the switch being turned on, the electric potential energy that was already created transforms through the wire into the fan motor, creating a magnetic field, which further transforms into kinetic energy, more specifically mechanical energy, moving the blades of the fan. Also, some of electric potential energy gets transformed to heat and gets lost while transferring through the wire into the fan and motor. After that, the kinetic energy from the fan will transfer the energy to the bowling pin, causing this to move. And this is just a transfer of kinetic energy. Then the kinetic energy from the bowling pin will transfer over to the lever, and then that lever will transfer that kinetic energy over to those dominoes. And then here the dominoes will start falling on top of each other, another like potential to kinetic transformation. And as the final domino falls onto this popsicle stick lever, it goes from kinetic energy and gains the potential and will fall back. From kinetic energy, the domino gains the potential and will fall back to kinetic energy. And after that, the end of the lever will hit the ball. Here the kinetic energy passes through the popsicle stick and transfers to the ball so the ball can roll into the cup.